Good evening. What I wanted to do tonight was I wanted to finish the lecture on disc brakes for those that were not in class tonight. We've kind of put an end to this chapter. We're getting ready to move on to drum brakes next week. So I wanted those that weren't able to see the end of the lecture today to be able to view that. So I'll re-record it here tonight. Um, there'll be a test on disc brakes on Monday. And so before I end this video, I will do a short review to prepare for that test on Monday. Um, what I would like to do is get into drum brakes. Start the lecture on drum brakes Monday, and then we'll take this test and start a lecture on drum brakes, and we'll for sure get into the lab on Monday evening also. Where we left off on our lecture on disc brakes was finishing rotors off the vehicle, and I think everybody in either class that wanted the opportunity to turn these rotors on the machine back there had the opportunity to either turn a rotor or assist, and I think everybody took the opportunity to do that. And so I think we're probably in pretty good shape as far as doing that. As a review, if we're going to turn these rotors, this is a hubless rotor that they've got here, but we need to get it very clean. Any debris, rust, or dirt or anything that gets between our cones that we set this up on and the rotor itself will cause it to run irregular, run crooked, so it will shake and shimmy when it's on the car. It'll have run out on it. So we'll make sure we get everything clean when we set it up. Then when we do, we're going to turn the machine on and make sure that everything is running true on the machine. Anti-chatter band or anti-chatter pucks on the rotor. These little pucks, I really like these. I don't think our machine is set up with these. We were using the bands before, and they work fine. But I like these. I like this type here too. This is a different brand of machine than the ones that we have in our lab. What they're wanting to do here is position the cutting head about a quarter of a way from the outer diameter of the rotor, turn on the lathe. What they're wanting to do is cut off any ridge that might be on the outside of the rotor. So they set the cutting bits to the proper depth to machine that ridge off, and then by hand, slowly move the cutting head outward so that it removes that ridge on the outside. And again, the reason for that is if we have a ridge that's, say it's 30 or 40 thousandths tall, and we set this rotor up to cut 5 or 6 thousandths. Well, when it gets to the end, it hits that ridge, it's going to have that 5 thousandths or 6 thousandths that we programmed into it, plus the amount of that ridge. And so we want to make sure we take that off beforehand. Once it's removed, once that ridge on the outside of the rotor, that wear ridge is removed, we move the cutter head all the way to the inside of the rotor. We dial in whatever cut we're going to make. Usually it's kind of a minimum of 4 thousandths per side. To cut those is what I've always used as a rule of thumb. So we're going to set those and lock everything down, and then engage the automatic feed. And remember that now on this particular machine, on this slide, it's an AMCO machine. It's got a fast and a slow. You can either put it in the fast position or the slow position. On the machine that we have out there, it's got a knob where you can control the speed a little more. You have a few more choices than you do with this AMCO machine. But again, the faster that you feed those cutter bits across the surface, the coarser your finish is going to be. So if you slow it down, you get a smoother finish. So you're going to do this and continue to make cuts on this rotor until you get all the damaged surface removed. Remember beforehand we've measured this rotor with a micrometer and tried to determine that it had plenty of material for us to go ahead and make these cuts that we're doing. So it says, if necessary, perform a finish cut on the rotor, and it's usually done on slow speed. Do a real slow feed on it to do a finish cut. It'll be nice and smooth. And when you're finished with that, we can use sandpaper on one of these little high-speed grinders or a cordless drill or whatever, and use a sandpaper disc, and it takes that spiral finish off of the rotor and puts a non-directional finish on it. It's good for breaking in the brake pads initially. Then when we're done here, what they're doing here is they're going in and they're measuring this rotor to make sure that it's that's thick enough to meet specs. You know, I would hope that by this point we would already know that before we went in and put all this work into it, that it was gonna make spec. But anyway, you just want to make sure that you do not use an undersized rotor ever. Again, the rotor's ability to dissipate heat it goes right along with how thick the rotor is, how much material it's got, how much metal it's got. And so if you cut too much metal off of it and the rotor's too thin, it doesn't have enough substance to dissipate heat very well, and the rotor will overheat and it'll warp and have run out and stuff in it. When you're all through, the best way to clean something like this, whether it's a cast iron rotor like this, or whether it's an engine block that's been machined or whatever, hot soapy water. Man, hot soapy water will take off all those little metal particles and stuff and clean it up really well. You know, obviously now it's going to leave it clean, but it's going to leave it prone to rust. So you need to get it dry just as soon as possible. And that hopefully with that we've got rotors there that have been machined and ready to put on. Replacing wheel studs. Now, we've done this in lab, I think Monday night, we replaced some wheel studs. So inspect the studs, look them over for any damage. Look for signs of studs that have been stretched. As if they've been stretched, they'll have a portion that will be neck down or smaller where that stud has been stretched. And remember that any fastener, for it to have a clamping force, the bolt has to stretch a little bit. But when you over tighten them and overstretch them, it's gonna neck it down. Is what's called neck it down, and it's gonna have a thin part in here where it's been overstretched. So be on the lookout for that. Look for anything where it's been cross-threaded, any corrosion, or this one's got some rust on it, needs to be cleaned off, and determine whether the stud can be removed. Then once you determine you're going to need to change it, determine if the stud can be removed with the flange on the vehicle. So some of them you have to take the hub or the flange off to be able to get the studs out. Now this one has got looks like a cutout section here, a recess, that as long as you have the stud turned in this position, looks like it would probably come right on out. We could just knock those out. It says to perform the drawing in method, position the flange so the stud has clearance on the back side to be removed. Remember, the drawing in method is where we took our new stud and positioned it on the hub and put a couple of washers over it, and then threaded the lug nut back on it with the flat side up against the washers, the flat side of the lug nut up against the washers, and we tightened that until it pulled or drew this stud back in where it's flush with the back of this hub. Guys, remember this hub flange. Remember, it has to be flush. You can't leave that. You can't leave any clearance at all between these two. If you do, that could you hit a bump that could move into place, and you lose your wheel torque. So make sure those are flush up against that and pulled in against that tight. So once we've determined which studs we're going to replace, here they're just taking a hammer and just knocking it out. If you have a big piece of brass or something, that might be helpful too. Be really careful when you're using a big hammer like this that you don't damage any of the other studs or the hub or anything around it. That you've got your recess lined up here and you can knock that out. Remember now, on some of these brake hubs and wheel bearings, there may be a tone ring or reluctor for the analog brake sensor back here. So make sure that there's nothing back here that you're gonna hit with that stud when you're knocking it out of there. Once you've got it out, you take the new one and position it in. These little edges here, they call them flutes. Line those flutes up with the edges that were originally in the flange here. Put on your flat washers. We're using the flat washers so this doesn't bottom out when it comes through here. And then you put a nut on here and you start tightening the nut. As you tighten the nut, it'll start drawing this stud in to the hub. So you make sure you get it all the way in where it's flat. And then when you take the nut off, check it for any damage or anything. Make sure that it didn't get damaged while you was installing it. For the hub style, here's one where we're going to use a hydraulic press to take these out. We're going to remove this rotor and hub assembly from the vehicle. It says use the manufacturer's procedure to do that. We're going to put it on a hydraulic press. And guys, these hydraulic presses make a lot of pressure. So be really very careful when using those. When you're getting ready to press this stud out, look underneath it, see what it's going to hit, or if it's going to hit anything underneath, and then go ahead and press the stud right on out. Believe me, that hydraulic press won't have any problem at all with those studs. So you take your new stud and align it with the hole in the flange and line up the flutes just like on the one before. Then we really need to support this rotor well. I see we're on the hub here on this one. They've got it set up on these blocks so that they can press against it. You don't want to press against the studs or the hub or anything like that. You really want to set this up and support it well. Again, like I said before, these hydraulic presses make a lot of pressure. So they've done that, and they've got a tool here that goes between the stud and the press so that they can press on it. Here's the tool. And it says press the stud until it bottoms in the flange, and your hydraulic press will just push that right in without any problem at all. It says to complete the drawing in method and the hydraulic press method, verify that each stud is fully seated in the flange. So again, that it's fully seated. So that's, we talked about that in lab Monday, and so that kind of finishes up replacing studs on these wheels. Guys, I've had to do this on the side of the road where I remember one particular vehicle. It was a Dodge. I forget what they call their SUV now, but anyway, somebody had left a wheel loose on it, and it had torn a couple of the studs up, and we had to change those on the side of the road, and really didn't have much trouble doing it. We just knocked the old ones out and went and got some new studs and pulled them right in. We had to replace all the lug nuts, but we were able to do that pretty successfully right on the side of the interstate highway. Torquing wheels, again, something that sounds pretty straightforward, but we'll look here and find out that there's some areas of concern, some things we need to look at. Guys, a lot of people like to use these what's called torque sticks. Torque sticks are they look like a 1/2-inch drive extension with a socket made on the end of it, and they're set for different torques. If you use 115 foot-pound torque stick, then no matter how big and gnarly your impact wrench is, it's only going to go to 115 foot-pounds. If you use a 95, again, it's only going to go to 95. The thing I don't like, I do like them. I don't use them very often, but I've seen people that use them, and I know most of the tire shops use them. But the problem with them is if this wheel torques to 115 foot-pounds, and you put that torque stick on there, and you pull this thing here down to 115 pounds, you've cocked the wheel. You've already cocked the wheel, and so if you could start off with maybe a 70-pound torque stick and then use it do the star pattern. We want to start and we want to go around this wheel, and we don't want to pull it down on one side before the other. So we're going to on this particular one, my method is to use a torque wrench. Start with this one, torque it to 70 foot-pounds. Say this torques to 105 pounds. I'm going to torque it to 70, and then torque that one to 70, 70, 70, 70. And then I'm going to say 95, and then do the same pattern. Go to 95 foot-pounds, and then go to my final torque, which would be 105, and do the same pattern again. Then when I'm done, I'm going to start at the top, and I'm going to go around and check each one of them, just in a circle pattern, just to make sure I haven't missed anything. And I'll check them at 105 to make sure everything's torqued. And that's, when you do that, you're done. I've done this for a long time. I have never had a wheel come off. So that has served me well for a long time, that particular method. Lug nuts, several things about the lug nuts. Start the lug nuts with each wheel being careful to match up the surfaces. A couple of things about these lug nuts. You see it's got a taper here on the end. That taper helps to center the wheel. There's a taper on the wheel also. So when you screw these lug nuts in, they're supposed to taper the wheel, center the wheel. I'm sorry. Things to be aware of. Some lug nuts don't have this taper. Some of the Fords and some Dodges too. They've just got a flat washer made on the end of it, and there's no taper on the wheel. So what lines up the wheel and centers the wheel is just where it goes over the studs, and then it has a washer that goes against the flat part of the wheel, and that tightens down. Also, not every lug nut has the same angle of taper here on this end. So if you go buy a new set of lug nuts to replace some that don't look very good, make sure this taper's on the end is the correct one, because if not, your wheels won't stay tight. So you make sure you've got the right stuff, and then go ahead and torque those. Another thing to be aware of when torquing these, you know, a lot of people like to use an anti-seize lubricant or some sort of lubricant on these lug studs when they put them on there. And just understand that when you get that 105 foot-pound torque spec for that, that is a dry spec. So that specification is put out there for those lug nuts and studs being dry and no lubrication on them when you torque them. And if you use an anti-seize or some sort of lubricant, it's going to change that torque spec. So my recommendation would be, they recommend dry. I would torque them dry. It says carefully run all the lug nuts down so they're seated in the wheel. And again, that centers up. When you seat those in the wheel, that taper is going to line up that wheel and center the wheel up like it's supposed to be. Then you can let the vehicle down so the wheel don't try to turn when you torque it. And then go ahead and go through your torque procedure. And again, my recommendation would be, you know, just develop a pattern for the way you want to do things, and then stick with it. You know, if you find something that you think works well for you, until you see something that you think is an improvement, just go with your own sequence each time, and make sure that you get those all down tight. Come up with something that will stay with you each time, because you darn sure don't want to ever lose a wheel. This is once all the lug nuts have been torqued, go around them again, this time in a circular pattern to ensure you didn't miss any, and that's a really good idea. Just go around them here, and like if it's 105 foot-pounds and you've already torqued them, when you go around this, they're not going to move anymore, but at least you've checked them and make sure that they're not, you didn't miss anything. And this is once, if the vehicle is equipped with hubcaps and valve stem caps, reinstall them. That's something to notice about this valve stem here. This is a valve stem that has a tire pressure monitor on it. And on those stems that have a tire pressure monitor, this is a plastic cap that goes on there. And on certain ones of these, if you put a steel cap on these, it will almost like weld itself to that stem, and you'll not get it off. And I know from firsthand experience. So if that has the plastic cap that goes back on it, if you don't have one, just wait until you can get one. Don't screw a steel cap on this and expect to be able to get it off the next time, because there's a good chance you won't. Then you're going to get in and you're going to step on the brake, check the brake fluid level first, of course, and then step on the brake. Start the vehicle up, make sure the brake feels right and it's the proper height. Check your parking brake to make sure that it's acting right. And remember, we talked about cleaning off all the connections where we had the lines off with some sort of a brake cleaner that dries with no residue. It's real easy after you've done that to go in there with a flashlight and look at all your connections and see if there's any leaks or anything. If you've got it clean and dry, if there's any leaks, it'll show up immediately. Well, that's pretty much it for disc brakes. I think we've covered disc brakes fairly well. I looked over our labs in this chapter, and we've done every single one of them, with the exception of on the integrated style parking brake on the rear, pushing that piston back in. I brought a tool in tonight to school to show you guys the tool and how we do that. I wasn't able to locate one of those calipers out in the shop to use, but we did go through the procedure for pushing those pistons back in. Just remember that you cannot use a C-clamp if it has that integrated rear parking brake. That has to be rotated back in. That you have to push and rotate it. There's a special tool to do that, and you'll have to have the special tool, or you won't be able to perform those jobs. Hey, I'm going to go over here just a little bit. We're going to have a test on Monday night. I'd like for you guys to have a little bit of a heads up. Understand wear indicators for our brake pads. You know, we talked about the brake pads and the wear indicators. Some of them have a spring steel little wear indicator that's made right on the pad, that when the pads wear down, it will scrape on the rotor and make a noise, and that's your warning that your brake pads are getting thin. Some other cars have a little sensor or a little contact that's made in the brake pads or sits alongside the brake pad, so that when the brake pads wear down, it turns on the light on the dash. Just a different manufacturer's idea of the way it should be done. So understand both of those. Advantages and disadvantages of disc brakes over drum brakes. The main advantage to drum brakes or to disc brakes are that they can generate and transfer a great amount of heat. Remember, they have most of them are vented, but even if they're not vented brake rotors, they're out in the atmosphere, they're spinning. They've got that shield on the back directing air around them, so they're able to generate and dissipate a lot of heat, and that's their big advantage over drum brakes. Remember, drum brakes now, we generate our heat where the brake shoe comes in contact with the drum, and there's no way to get any air through that to cool those drum brakes. So disc brakes have a big advantage there. An edge code. I showed you some brake pads with an edge code. Edge code just means that on the edge of the brake pad, when you look down on the side of the brake pad, there's going to be some numbers printed on there, and that has to do with its coefficient of friction for the friction material on that brake pad. Called an edge code. There's going to be a question on the test about parking brakes. Remember that we have the two types mainly of parking brakes when we have a rear disc brake. It's going to be the top hat style. Remember that the top hat style has a small brake drum made on the inside of the rotor, and there's a set of brake shoes that go out and are wedged apart that they go against the inside of that drum, and that is our parking brake. It's all made inside the brake rotor. And the other is the integrated style that has the lever on the side of it, has a cable that pulls on the lever that spirals that piston, the center part of that piston out to make the brake shoes contact the rotor. So integrated style and top hat style will be our parking brakes. The integrated parking brakes work on the principle that the caliper pistons are forced out by that spiral, by that lever and that spiral shaft that's inside the piston, and it forces those out and pushes the brake pads against the rotor, and that's the integrated style, and that's what it works off of. On a non-integrated style, where we just got a regular brake caliper, if we don't have the tool, the correct tool to push those pistons back in to put on new brake pads, a C-clamp is perfectly acceptable to use. It's a fine substitute for the tool. My recommendation would be that you would put one of the old brake pads against the piston, and then put your C-clamp up to the brake pad. That'd save maybe probably damaging those pistons. If they have those phenolic pistons in there, the plastic-looking pistons, they damage very easily. So you don't want to use channel locks or anything like that, but just a C-clamp and one of the old brake pads works pretty darn well. Brakes dragging. If we have a disc brake that's dragging or trying to hold it's hard to turn, and it's like trying to lock up. Got some of the things that would cause that would be a brake hose that had an internal problem that would not let fluid return to the master cylinder, or possibly a piston. We've seen in some of our slides in our lectures, we've seen some brake calipers that had rust and stuff on the inside of them. It could possibly be that one of the boots is bad and it got some water in it and rusted up, and that would cause that caliper to stick, and that would make it drag. Those are the things that would do that. Master cylinder wouldn't have anything to do with that. Warped rotors wouldn't have anything to do with that. It would generally, if you've got one that's draggy like that, it's going to be a brake hose or a brake caliper. Dial indicator. If we use a dial indicator to measure a rotor, then we're measuring a run out. Remember always that a dial indicator measures movement, whether we're checking a run out or an in play or whatever. A dial indicator is going to measure movement, and so what we'd use our dial indicator for in a brake rotor is to measure run out. There's a question on the test that has to do with test driving a vehicle, and I'll just say if the vehicle is safe to drive, if there's not some reason that the brakes are going to totally fail. So if the vehicle is safe to drive, it's common practice to take the vehicle for a test drive before you work on it to try to verify the customer's complaint. Again, you need to know exactly what you're chasing, what the customer is complaining about, so that you can go in there and fix that. If we have a problem with the brakes, maybe a noise problem or something, and it's hard to pinpoint whether it's coming from the front or the back. If it's got disc brakes on the front and rear. If it's got the park brake that has the integrated type park brake, where the brake shoes clamp against the rotor, guys, we can apply the park brake. And not only is going to work on the rear, so a noise, if we apply the park brake and we can hear that, then there's a good indication it's from the rear. If we don't hear it, there's a good possibility it's coming from the front. So we use the park brake sometimes to isolate that stuff. Same way if it's got discs on the front and drums on the rear, we can apply the park brake and apply the rear brakes and see if we can isolate the problem that way. Just remember that on the integrated style caliper, pushing that piston back in is a whole different process than on just a regular brake caliper. We have to have a special tool to spiral that piston in the inside of that piston to put it back in. When you have the brake lines loose and they sit there and they drip, 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 guys, you can take and lightly apply the brakes and you use one of those brake holding tools. And what that will do is it'll block off the compensating port and it'll prevent that fluid from leaking. You don't want to clamp vice grips or anything like that over the line, over the hose. It will damage the hose, and that's some of what I'm talking about before, where those hoses can break down inside and cause issues. And so you don't want to do that. But if you'll just step on the brake a little bit and put one of those brake holding devices and hold that brake on slightly, it will close off that compensating port, and you won't have those issues. Any dust, brakes, whether it's drum brakes or disc brakes, there's going to be some dust involved. Guys, that should always be treated like a hazardous material. I know they don't use asbestos anymore, but still, there's different ways that you can clean that off of there. You don't want to put it in the air. You don't want to try to dust it off or blow it off with an air hose or anything like that. Some people use a vacuum cleaner that has a real fine filter in it, like they would use for drywall or something like that, and to take that dust and stuff out of the brakes. Some people, what I generally use again is I'll put a pan underneath it to catch it, and I just spray it all down with brake clean and wash that stuff off of there. If it's in liquid form, it's carried off in liquid, that it's not going to be suspended in the air, and you're not going to be inhaling it. So that's the way that I would deal with that. And then later on, afterwards, after you get all that stuff off there, you may have to go back in and take either brake clean or some sort of solvent and do a little bit more detailed cleaning. But again, what you don't want to do is put that stuff in the air. When we're inspecting brake pads, we're going to check our brake pads. We're going to check for wear, obviously the thickness of the pads, and if the pads are going to be usable or not because of how thick or thin they are. But we also want to look over all the brake hardware, all the hardware that holds the pad tied into the caliper, and also to keep that keeps it from rattling. Those types of things, you want to look all that over. Make sure the pads have even wear. If we would have say one pad that's completely worn out and another pad that didn't have much wear on it, then that could be an indication on a sliding or a floating style. That could be an indication that we have some binding and our brake caliper is not floating like it's supposed to. So our piston just coming out and pushing that one pad against the rotor, and that's all that's happening. So you may have to take that apart, clean the slides, and clean everything all up, and make sure that rotor will slide properly, so that both pistons can be applied, or both pads can be applied to the rotor. If we've got one side that's worn like that, and it's a fixed brake caliper. Remember, a fixed caliper is going to have at least one piston on each side. If we have one side wore out and the other side's not, we could have a problem either of not getting brake fluid to one side, a bad line or something internal in the master cylinder, or it could be a piston sticking on one side of the caliper. So look those over and make sure that they're wearing evenly side to side, that the brake pad is not wearing crooked, where it's wearing one part of the pad more than the other. And look those pads over for those situations, and take whatever actions necessary. When we set up our brake lathe on our brake rotor that's got a hub inside it, do you remember what we set up on to machine those and make sure that we got them centered perfectly? You know, on the open style, they've just got a hole in the middle of the brake rotor. We used our clamps and a cone to center that. But off on the type that's got the hub, guys, we centered up off of the wheel bearing races. The wheel bearing races are still in there. That rotor on the vehicle, it runs on those wheel bearing races. And so when we set our brake drum machine, our brake rotor machine up to turn those, if we use those wheel bearing races to center off of, then we should have a close to perfect rotating surface to do that. So that's a good way to do that. New wheel studs, and just we talked about a minute ago. They're either gonna be pressed in or drawn in. Those are the two methods for doing that. We also talked about brake studs when we're looking at them for damage. We're gonna look down for a necked down area. We're gonna look for anything that's cross threaded or damaged or broken. When we're deciding how to do those. Last couple of things here I want to go over. Brake rotor thickness. Remember, when we're checking for the rotor for being parallel, we want both surfaces to be parallel with each other. One way we check that is we're going to go take a micrometer, dial indicator, or something, or not a dial indicator, dial calipers, and we're going to go around that rotor in 5 to 8 places and measure it, and it should measure the same all the way around. So that would be a good way to check those. And then the last thing is another one that we talked about, lug nuts. When we put those on there and get ready to tighten those down, they're to be put on there dry. We don't want to use any sort of an anti-seize or anything like that. We just want to put those on there dry. And with that, I'm going to shut this down for tonight, and I'll see you all Monday. Again, my hope for Monday night is that we'll take the test over chapter 46 over disc brakes. And then we will get started on drum brakes, and I'll try to have some interesting labs to do on Monday night, and we'll for sure get out into the lab. And we thank you all very much, and I'll see you Monday.